Okay, hello everyone. Am I audible? आवाज आ रही है मेरी? चलिए। नमस्कार दोस्तों, स्वागत करते हैं आप सभी का आज के इस सेशन में, जहां पे आपके लिए फिर से मैं लेके आया हूं सी प्रोग्रामिंग का नेक्स्ट पार्ट। और नेक्स्ट पार्ट इज कंसिस्ट ऑफ प्रोग्रामिंग। ठीक है, प्रोग्रामिंग विथ पॉइंटर, है ना। नेक्स्ट पार्ट में प्रोग्रामिंग तो है ही है, लेकिन है जो चैप्टर है डेडिकेटेड रहेगा पॉइंटर के लिए। बहुत इंपॉर्टेंट कॉन्सेप्ट है पॉइंटर का, और पॉइंटर से क्वेश्चन आने की प्रोबेबिलिटी बहुत ज्यादा रहती है। ठीक है, so now we are going to start with, again I forgot that this is an English channel, and again let me give you a small little bit of introduction that I welcome all of you to this session of C programming, fourth installment. And here we are going to discuss one of the very important topic which guarantees question in the examination, GATE examination, and which is pointer. Very confusing. Most of us including teacher also struggle with pointer, but I'll try to simplify this particular topic which is having very high weightage. Okay, so let's start with pointer today. Now, so the last class what we have covered was related with recursion, and I told you three types of recursion, that is tell recursion, single recursion, tell recursion, non-tell recursion, and the last part was multiple recursion. Okay, so this three recursion we have seen. We have seen recursion tree, okay, multiple recursion we have seen. Today is we'll see the single pointer, single direction, single point. Acha, we'll see the pointer. We'll see a single pointer, single and double pointer. Triple also we can see, but it will be, I think, more for one day. Single or double pointer we will see. We'll see pointer passing call by reference. Let's say call by reference. We'll also see one case where a problem created by the pointer, and that is called dangling pointer. Okay, so we'll also see dangling pointer today. Okay, so these are the topics I'm planning to cover today, and let us start. Let's begin with this. Now, register. No register right now. We'll begin with pointer topic. So what exactly is the pointer here? Let's start with this very simple thing. What exactly is pointer, and what is so confusing about this pointer? Why there is a so much confusion around this variable pointer? Good morning, Nishu. So first of all, pointer is a variable. The first point is the pointer is a variable. Okay, now variable. So now, like the normal way we declare the variable, similarly pointer variable is also declared. So pointer is simply a variable. Okay, but now the capable of holding address of another variable. So pointer is a variable and which is capable of holding address of another variable. So it's just a normal variable which can hold the address. Good evening. Now how can we access the address? The main question here arises that how can we access address of a variable? Memory, how can we access it? So how can we access address of another variable? Now this is something which is maybe problematic, and Java has not at all allowed programmer to reach to the memory. It never allowed. Okay, and that's why the concept of the Java virtual machine, that okay, you will not touch the actual machine, you will run on the virtual machine only, JVM. Okay, so and the reason was that the failure of a big project or big application is that there are two reasons why a big project or big application fails. The first reason is that bad memory management. Okay, so memory management, if it is the responsibility of the user, the users, programmers may tend to make the mistake. So it is not given to programmer. And second is a bad exception handling. These two things was main concern when Java was coming. Already there was C++ was there, and it's not that people are not working in C++. Still in the system level, there is a lot of work done in the C++, especially those who are in, let's say, hardware based company, the Qualcomm, the Intel, Nvidia, they still work in the language there is for C++. Okay, so big package, big company, so they work in C++. And the usual people work in Java, .NET, full stack. Okay, so how can we access the address of a variable? So by using a ampersand operator. So there is a one operator, ampersand operator, and ampersand operator you can apply to any variable. int a is there, and you say ampersand a is address of the variable. Okay, so now this can be accessed by using address of variable. Okay, so now there is an ampersand operator. Now another question that arises, that how can I can access the address? So now the second question is that how can I assign this address to another? Beta ये तुम I guess you message me personally, DM करो, I'll forward your resume. Now to declare a pointer variable, let's start with this. To declare pointer variable, what you need to do is you have to write int star ptr. Okay, now there is a very significant difference between int ptr. Integer, ptr is integer type. The moment you put a star over there, then it becomes ptr is pointer, points. So how to point? So like this, this is the way you point, and you may have seen some many statues pointing towards that. Let's go to that direction. Okay, so that same is a pointer basically. So that is a pointer. So it's a pointer, ptr, as the name suggests, but name is nothing, the data type is important. ptr points to an integer, points to an integer. ptr points to an integer, and the meaning of this is that ptr holds address of another variable, address of integer variable. Let's write it clearly, integer variable. Now how can I assign the address? So two ways, initialization and assignment. So now the first thing is initialization. How can I do the initialization? And let me write it separately, because you should be very clear with this idea. There is a minute difference and later it will become a key concerned issue. Initialization, you declare a variable int a is equal to 10. Now if you want to initialize the pointer variable like this, int star ptr pointer variable, and that is equal to ampersand address of a. So the moment you declare, that time only you initialize it. Okay. What is the another way, sir? What is the another way of declaring the assigning the pointer variable? This is the initialization. So during star ptr is equal to address of a, same like a is equal to 10. Initialize, pointer also initialize. Assignment. How to do the assignment? So in that case, it will be declared separately and initialize integer. Pointer will be declared separately, that is here as ptr. And now you say ptr is equal to ampersand of a, address of a. Now see the very clear difference, and notice the difference that when I am doing the initialization, that time there is a star and it is mandatory, right? It is mandatory that because it's a declaration, so I have to say that it's a pointer variable. But after that, when I am assigning the address, I am saying ptr is equal to address of a. There is no star. There is no star. Star ptr I have not written. ptr is equal to address of a. So point to be noted. Okay. This is the way initialization work. This is the way initialization. This is the way assignment work. Now why it becomes challenging? Why the pointer become challenging? And after that we'll solve one or two questions to deal with that. It is something like that one memory location can be accessed by multiple variable if I can use the pointer. Okay. And that is the problematic thing. Now let me draw the diagram. This is a variable a, and this is the best way to deal with pointer by drawing the diagram. A is 10. Okay. Then you have a pointer variable which is ptr, and now suppose this address is 100. Okay, suppose this address is 100. So now if you want to assign, once you say the statement ptr is equal to ampersand address of a, this 100 will be here. Now this is the arrangement, and if it is a pointer, you will find that this arrow will be there. As I said that it is pointing in this particular manner. This is saying go here, don't talk to me, go here. Okay, we can talk to this location also, but if you can go here, point. That is the idea. Now here let me say few values that can be printed here, and just feel that what variable is what value is what. So ptr is equal to, we said address of a, ampersand of a. Now if I want to print a, no doubt it's a trivial thing. I'll say printf %d and I'll say a. So a will be printing here, in this case is 10. Okay. Now if I say printf and I say %u, that is my favorite, but I say %p, and I say ampersand a, address of a. Okay, %p, another one format specifier is for printing the address. Format specifier for printing address. Okay, so ampersand a, address of a, I have written %p, p will print the address here in this case. So %p is for format specifier for printing address. Now if I say printf one more time, understand the variable %p, and I say only ptr. Okay, ptr, and last but not the least printf data type is important, %d, and you say dereference ptr. Yeah, dereference ptr. Okay, now which is which? Now in this there are two addresses are there. This is address and this will print in this setup. This will print the value 100. Acha, one more thing, one more important point. You cannot assign address that 100. Some student will say now 100 will appear, sir, when I run this program. No, 100 will not appear. Okay, allocation, which memory location it will go, it's not in our hand. Okay, so this is a reference value or assumed value. Okay, this is not actual value. Addresses, it can go anywhere. So this is an assumed value and it can be any other value. So don't say, or sir, I run the program and it was not giving 100. It will not give 100. It will give you some hexadecimal value if you run for percentage p. Now a, you know, it will print the value 10 value. When you say ampersand a, it will print 100 if it is their address. If you say ptr percent p, it will give you 100, which is again address. And if you say dereference ptr, it will gain 10 and that is value. Now this is important, that a can be accessed by using variable a. Fine, this we have, this we know, this is the basic rule. But I can also use a ptr for accessing this variable a. That is important. I can use ptr to read the value location, to update the value, and I have to use dereference ptr. I can use dereference ptr to read and write the value over here. Clear? Now on that note, let's have a small problem and we will call it as a pointer question, and let's solve this question. So let's start with now suppose the variable int a1 is equal to 10 and I have taken int b1 is equal to 20. Suppose I have taken int star ptr 1 is equal to ampersand a and int star ptr 2 is equal to address of a. Then I say a1 is equal to address of a1. Then I say a1 is equal to a1 plus b1. b1 is equal to a1 plus b1. Okay. Then I say star ptr1 is equal to star ptr2 plus star ptr1. Okay. Then I say ptr2 is equal to address of b1. Then I say star ptr2 is equal to 2 times star ptr1, and then I say printf %d. Now everyone will solve this question. Okay, this is a good question to clarify your understanding. A1 and B1. This is how the question comes in the examination, and then say return 0. Come on. Let's see what exactly you can do with this question. A1 10, B1, P1 is equal to address of A1, PTR2 address of A1 getting updated A1 plus B1, B1 getting updated A1 plus B1, PTR1 is equal to PTR2 plus PTR1, PTR2 is equal to address of B, PTR2 is equal to 2 times PTR1, fine, 2 times address of PTR1, okay, let's say this way, 2 multiplied by, okay, dereference PTR1, and then you have to find the value of A and B. Can you guess the answer? Can you find the answer for this? Anyone? हाँ स्टार बी, हाँ एड्रेस ऑफ B1, यस PTR2 is equal to address of B1. No, dereference PTR2. I think it is correct only. It is correct. It is correct only. This we are assigning address. This we are updating the value. चलिए answer. Let's give the answer. Let's answer this question. What do you say? Okay. No one? Somebody must be able to answer this question. I still believe it is doable. Chalo, let's see. So see, this is a complicated one. I have not started with a very simple problem. It's a complicated one because many thing is happening. A is getting updated PTR1, then PTR2 changing its address to PTR1, and please systematically learn this thing. This problem is going to free any doubt if you are having in your mind. Okay, so you will be free from any confusion and doubt if you are able to successfully answer this particular question. Let's verify. Let's go systematically. So I'll have this variable over here. Let's start with A1. Let's have a A1 value 10. Let's have another variable which is B1. Okay, B1, and that is equal to, in this case, is 20. Now we have PTR1 is equal to address of A1. So PTR1. Okay, let me change the color. Address of A1. So let's have, this is 100. So this will be 100. PTR2 will be address of A1, both the cases. PTR2 also. So this diagram is very important. PTR2 is also address of it. So this is also 100. And suppose this is 200. So now here both the addresses are assigned, PTR1 and PTR2. Both are assigned to A1. And pointer wise, if you say, then it is pointing to this location, and this is also pointing to this location. Okay, both are being pointed to this particular location. Great. Now here the updation starts, and we have to execute 5 statement correctly. Let me write it. Now when you say A1, this is the first statement. I have to execute 5. So now A1 is equal to A1 plus B1. So now it will become 10 plus 20, and that will become, in this case, is 30. Okay. So now the first change I will write here. This is 10, and now this become 30. B1 is equal to A1 plus B1. Okay, B1, second statement. So B1 is equal to A1 plus B1, same statement. But now we have to be very careful in this time, because updation, and you let me know whether you are getting it or not. A1 is now updated to the value 30, and B1 is still 20, and that will become 50, and now we'll update the value b1 and that is equal to 50. Please let me know whether it is clear or not, otherwise again I will explain to you. So 2 statement done. Now dereference, third statement, dereference PTR1 is dereference PTR2 and plus dereference PTR1. Now do the dereferencing. So now which location to update? This location. And what does it say? That you add the value from the PTR2 as well as PTR1. Up the thing is that you look at the two edges, they are both are pointing into 30. This is also pointing 30, this is also pointing 30. So both values are 30. Let me write the third statement, so it will be very clear to you. Dereference PTR to be 1 to be updated with dereference PTR1 plus dereference PTR2. Both are pointing to location which is this, so 30 plus 30 and that is equal to 60. Okay. So this value updated to 60. This. Now something different happened in the next line. You tell me, because it's a not long question, but yes, for the first question it is a bit longer. Now the PTR2 now pointing to B1, okay, address of B1. So now this will be no longer valid and now it will point to B1 like this. Now you say fourth state, last statement, which is fourth is missed, the fifth statement, and it says that dereference PTR2, just now PTR2 pointing to this, is a 2 times PTR1, 2 times PTR1, dereference PTR1, that is equal to 60, and that will become 120. So this 50 changes the value to 120. You come out and say A1 and B1, A1 is 60, B1 is 120. That is the pointer for you. 60 and 120 is the correct answer for this one. Okay. Now tell me whether you are able to follow, understand. You want me to repeat anything you want, I am going to explain you one more time if you required. Otherwise tell me 1, 2, 3, 4 is missing because this is in white, it is written. This is the fourth step. This is the fourth step. This is the fourth step. Fine. Now let me know whether it is clear to you or not, and otherwise we'll move forward. I need a feedback. Is it okay? Repeat or clear? Only two possibilities are there, whether I should repeat it or is it clear to you? Okay, good. You say okay, I'll be happy. Okay, I'll be able to understand that what exactly happening in this. Good. Now, now please answer this question if you are okay with that. This is the question for testing. This is I am having for you to testing. If you're okay, then please answer this question. Oh, okay. This operator star PV and this operator 5 is equal to, you can write here, dereference PV multiplied by 32. Okay, this if you are not able to aware of it, I am writing it this operator. This operator, if you are shifting left, shift left, okay, shift left operator, shift left operator, then it is equal to multiplied by 2 to the power of 5. It is equal to multiplied by 2 to the power of 5. So now you tell me what is the answer. Let's see, and then we'll go for double trouble, double pointer will go after this. Good. Chalo. If you are able to approach the question and you are responding as an answer, I guess that yes, you are doing well. Okay, you are doing well. So let's have this very clear, that if you are able to approach the question, you may not be able to reach to the answer, but if you are finally able to approach the question, then yes, you learn something. Okay, so let me say one more time. You see, this is equal to 32 and you have to say the answer value of A and B. Take your time, no issue. I am here only, I am not going anywhere. Okay. So I got A and B. So I'm glad that nobody is saying C and D. Okay. Great. Good. So let's complete this problem. Now A and B, variable A, variable B, variable V is equal to 3. Okay. Just have a clear picture and it will be sorted. Now we have a pointer to V and there is a pointer to PV and it is equal to address of V. You assume anything that it is equal to 100 and this is 100. Okay. A is equal to 2 times dereference PV plus multiplied by 5 plus 5, sorry. Look at this statement and let's have very clear, let's understand this statement. A is equal to 2 multiplied by dereference PV. Now when you do the dereference PV, diagram says it is equal to 3. So it will be 3 plus 5 and that is equal to 16. So A value updated to the value 1616. Okay, 1616. Now after that, what happens is very different, different from the previous question. Something similar is happening, that PV changes address to A. Okay, so let me write green and now let's have this address is 200 and now this address changes to 200. So now I am just this is changed and now the new address become 200. It may happen, not loyal. Now B is equal to 2 times dereference PV. Now very important part is that now the address of PV has been changed to 200. Now it is pointing to this. So now as I said, 2 multiplied by this dereference PV is 16 and right shift by 5 position. Let me tell you, I already said left shift. Each left shift multiply the number by 2. Positive, negative doesn't matter. Okay. Each left shift and that is why I said that this is equal to multiplied by 35. So this will become 2 multiplied by 16 multiplied by 32. And if you look at properly, this is 2 to the power 1 multiplied by 2 to the power 4 multiplied by 2 to the power of 5, that is 2 to the power of 10. Okay, and that goes here is equal to 1024. Are you able to understand this question? multiply, and another is left shift operator, then it is divide. Okay, then it is divide. So right now it is multiplied. So 1024 multiply operator. Okay, multiply operator, and it will be like this. Good. Now let's come to the one more problem. Can we do one more problem here? Very interesting and very let's do one previous year question. This is an interesting question. Would you like to attempt? We are passing the value print xy. Let me write here. Output we need to find. Printf is there, so we need to find the output. And the function called here is print xy, and within that we have 1 comma 1. Okay, so now we are calling this function. I told you function day before yesterday, recursion before recursion, it was function, but it is just plain function, but just a one pointer variable. Please answer this question. If the function called is print xy 1 comma 1, go ahead, answer this. I am here so that you can see the entire paper. I am here only. Entire question. Good. Anyone? Come on. Attempt it properly, because if you don't attempt, we will not able to understand. Chalo, I think you have already noticed that where the question is. Even if I here, okay, I will abstract. So I should go this side, but there is no space. Okay, come here. Come on, Harsh. App gallery. I love spammers. Huh? They are out of the world. They are out of the world. Great. Now let's have this. They are in their own world. So now there is a printf xy, and x we are passing the value as 1, y we are passing the value as 1. Now there is an integer pointer int star ptr. PTR x is equal to 0. So let's have change the value to 0. Now it says that PTR is equal to address of x. PTR is equal to address of x. Ampersand x. So now if PTR is this, hold the address. Now you can take burden of writing 100 and you can write 100. What you can also do is rather than writing this, put it like this. PTR is equal to address of x. Now it will be here. Now PTR is equal to address of x. Yes. Y is equal to dereference PTR. So Y update with the value dereference PTR. Y will be updated to the value in this case is 0. Okay. Y will be updated to the value 0. Okay. So Y will be updated to the value 0. Now here 0, Y is equal to, and dereference PTR. Where is PTR? Dereference PTR is equal to 1. So where is dereference PTR? This. So see what is happening. X becomes 0. Fine. Then PTR is equal to address of x. So this PTR is having address of x. Address of x. And then Y is equal to dereference PTR. Y is equal to dereference PTR. That means Y is equal to 0. And then dereference PTR is equal to 1. So one more time this is updated to. So x becomes 0. PTR takes the address, we assign the value by dereferencing, and again PTR becomes 1. So now if you print the value, that will be in this case is 1 and 0. So 1 and 0. Sir, I have a ESE paid batch. Will it cover the entire SSC JEE syllabus, or do I need to study from other sources? Is the paid batch is enough for SSC JEE? Has a more theory question. Okay, I have no idea. I have no idea about SSC JEE. You're asking to wrong person. Really I don't have any idea. It's not that I don't want to answer. I really don't have an idea about this SSC. Now let's come to the double pointer, double trouble, and the trouble name is pointer, double trouble pointer. Okay, A. Then we have one single pointer dereference B. Let's have this also a bigger one. A, B. B is a pointer and it is having address over here. Suppose A is 10, B is having address of A, so let's assume it is 100. This will become 100. This is C. Now data type is very important. Data type is very important here. When we say single pointer star B, it contain address of a single variable, integer variable, address of integer. Okay. When you say double star C, okay, when you say double star C, now understand C will take address of a pointer variable. Remember, pointer variable. Now this will be keep on going. Okay, this will be keep on going, that a pointer variable, single pointer. So double will take address of a single pointer, triple will take address of double pointer, and 4 quadruple pointer will take address of a triple pointer. This is how it works. Okay, this is how it works, and it will be, you know, you can keep on copying this thing. Let's have a little bit demonstration of this in this funny thing. Okay, let's have a little bit of demonstration of this funny thing. It's very simple if you try to understand in this manner. Is my screen is visible to you? Yes, it is visible to me, so I guess it is visible to you. What I am saying is that how this indirection works, that if int A is equal to 10 and if I declare int star ptr1, star ptr, let's say star ptr, then star ptr will take ampersand address of integer. Now if I take double pointer double star ptr1, you cannot take the same name. Now this double star will take address of a single pointer, the address of ptr. If you take triple pointer ptr2, then it will take ampersand address of ptr1. If you not give, it will give you problem. Okay, it will give you problem. Now if you take 4 times pointer, okay, 4 times pointer, it will take address of ptr2. So triple. Okay, this is how it works, and you compile it. One, two, address of ptr, and then triple star should be address of ptr1. Is it the case? Address of A, it is correct. Still it is working. Now it is correct. So what was the issue with this? PTR name was wrong. Oh, name. It should be 3. Okay, it should be name was different. See this, hello world, properly printing. Okay, now see, so now how to understand this? Single pointer will take address of integer, double pointer will take address of single pointer, triple pointer will take address of double pointer, 4 time pointer will take address of triple pointer. Now very simple, a plus plus, okay, a plus plus, dereference ptr plus plus, okay, double dereference ptr2 plus plus, okay, triple dereference, triple is what? PTR, acha PTR plus plus, then PTR double dereference PTR1 plus plus, triple dereference PTR2 plus plus, and and 1 2 3 4 PTR3 plus plus. Okay. Now with this indirection, I will draw the diagram. Do not worry about this. Not at all. Do not worry about this, that I will not draw the diagram. Okay. Do not worry about this. 32, 30. Any C compiler has to minimum 32. Maximum there is no cap. Minimum 32 must be in direction it can support. It has to support minimum 32. Okay, it is designed to support minimum 32. Now this a plus plus will increment, it will make it 11. This will make 11 to 12. This will make 13. This will make 14, and this will make it 15. If I am correct here, then hello world %d and a should give me 15. Okay, I believe I am correct. Let's see. 11. Okay. There is a small issue. That is called precedence, and because it is first associating with this and then later it is dereferencing. Sorry, I need to write in this manner. Otherwise, plus plus will take the precedence. You are not aware, but I should write, either I should write this way, okay, then I'll get the 15, there is a issue, or I should write plus equal to 1, that will be fine, okay. Then I can say that, okay, lower precedence operator, then it will be plus equal to 1. I have taken a high precedence operator plus equal to 1. What do you say? Huh? Will it work? Plus equal to lesser precedence than dereference? Huh? I guess so. Huh? So now it is 50. Okay. So this is the way the double pointer works. Huh? This is the way double pointer works. Okay. So here it takes the precedence. Huh? So let's come back to our lecture where we are doing this. Okay. Double dereference. How does it look like in the diagram? So let's see this, that C is a double star C, okay, double star C, and now C will take the address of B and it will go in this way, suppose this address is 200, so now it will be 200. Now you put more and more star, so it will be keep on incrementing, in this manner. Okay. Now see this problem, A is equal to A plus 10, okay, A plus 10, so this 10 will become 20. Now second statement, dereference B is equal to dereference B plus 20, so you do the dereferencing, go to this place and then increment it by 20, so now it will become 40. And now if by using C variable, C double pointer C, you want to access A, how to access? Double dereferencing. So double dereference, this is one dereference, this is another dereference, double dereference C is equal to 20. So now this will become 60. Okay, this will become 60. This is how it works. Okay, this is how it works. Is it clear to you, everyone? Is this question is clear to you? Is this question is clear to you? 60 is the answer for this. So if you are creating compiler, then it has to support minimum of what? Minimum 32 in direction like this. Minimum 32 in direction like this. 60 is the answer. Very good. Okay. Let's have one more question and then we'll wrap up the session for today. Come here. int A is equal to 60, B is equal to 45. Okay. int star ptr is equal to ampersand B. Okay. And int double star ptr1 is equal to address of ptr. Definitely it will take address of integer pointer, otherwise it will not work. Okay. Now dereference ptr is equal to A multiplied by 2. Okay, dereference ptr is equal to A multiplied by 2. Then ptr is equal to ampersand address of A, and then double dereference ptr1 is equal to double dereference ptr1 minus 10. Okay, and then last but not the least, printf percent d A comma B. Tell me the answer for this. Return 0. Tell me the answer for this. A, B. I have taken single pointer that point to address B. I have taken double pointer consist of address of PTR. Correct. Dereference PTR is equal to I modified A 2 times. Okay, A 2 times. Fine. Then I change the PTR address and then I say double dereference PTR1 is equal to double dereference PTR1 minus a 10 and then I say print A and B. Okay, print A and B. Can you find the answer what value it will print, and then we'll stop the today's session. Come on guys. Come on. Can answer this question. मितेश लास्ट ईयर आपसे पढ़ा था सर, आपसे पढ़ा था 640 इसको. जस्ट गॉट अ मेल फ्रॉम आईटी जोधपुर फॉर क्वांटम टेक्नोलॉजी. Oh, very, very congratulations. Very, very congratulations to you. You are not the only one. You are having this success. There are many more success stories, but again, we are not able to hear from every our students. Okay, every of our students we are not able to hear. But let me tell you very frankly, if somebody says and somebody comes and inform us that sir, we got this score and we are joining this particular college, we are very happy for you as a teacher. Not only me, the entire PW faculty, every other branch will be very happy to hear if you are able to secure admission in any college and you are able to move forward. Okay, so very much congratulations to Mitesh for securing admission in IIT Jodhpur in quantum technology. You deserve it and your hard work's paid off. Okay, so again, very much congratulations to you. You can change your branch, that is okay. Yeah, we are always waiting for this, so that to hear from all our students that whoever is getting success admissions, you can change your branch, no issue in that. There are many interdisciplinary. This is masters, no? So master you can do in any specialization. Okay, answer. Let's come to this. Let's come to this. A is 60. B is 45. Pointer PTR is equal to B. PTR is pointing to B. Now you take the address or just make a arrow. Okay, so take an address or put an arrow. Double dereference PTR, another one is there, that is double dereference PTR. Okay, PTR1. So let's write PTR1, address of PTR. So now this is one arrow, two arrow, double dereference, two arrows. Okay, now let the game begin. This is the where game is beginning. So now PTR, dereference PTR is equal to A multiplied by 2. Dereference PTR arrow is here. A multiplied by 2. A value is what? 60 multiplied by 2. That is equal to 120. Okay, that is 120. So this 45 changes to 120. Okay, 45 changes to 120. Great. Then PTR is changing his address to A. Okay, address to A. And then we say double dereference PTR. Now see, double dereference. This is one dereference and that is another dereference. Double dereference PTR is equal to double dereference PTR. Now it will point to where? This 60. 60 minus 10 and that is equal to 50. So this 60 becomes here in this case is 50. You come here and print the value, that is equal to 50 and 120. That is the final answer. That is the double pointer for you. Okay, this is the double pointer for you. Very well done, guys. Thanks for responding. Thanks for having patience. This is all for today, and we are done. Okay, we are done for this session. And pointer, I taught you double pointer and single pointer. Probably, I'm not sure, but I'll tell you call by reference. Tomorrow 6:30, we'll talk about a little bit of array, and we'll also talk about call by reference. So I am saying yes, we'll do call by reference, and plus I'll give you some insight about array and pointer. Thank you all of you. I hope you enjoyed the session, and it is, I hope it is hopeful. Yeah, go ahead and ask your doubt. Good night. Did you join NIC, Nishu Kumar? बेटा क्वेरी जल्दी पूछ लो. ओके, बेटा he already moved on. I think he's already completed. They would unable to solve PYQ. You need a little bit. देखो PYQ अगर solve नहीं, if you not able to solve, it will go eventually. You one more time, if possible, you refer C programming recursion lecture, and then you go for recursion in algorithm. Okay, this is for you. If you are struggling with algorithm recursion, then I'll suggest you that please go through recursion lectures in C programming. Try to grab the concept properly, grasp the concept properly, grab or grasp whatever you feel better, and then go for recursion. Because when we come to the algorithm, in algorithm the main issue is mathematical aspect of the recursive function, right? So once you completely understand it, then go for mathematical part of it. Okay, so that way I hope it will get better. Okay, keep trying, definitely it will happen. PYQs, if you're not unable to approach, there is something problem with your understanding of concept. More revision, DPP solving and practice test solving. You solve them completely, definitely PYQ will be able to attempt. On that note, I'll stop.